My name is Willie Ballenthin.
Check.
Are you able to hear me?
Check, check.
Sure, no problem. Morning, everyone. My name is Willie Ballenthin. Can you hear me? Doesn't sound like it.
All right, so
Check.
check.
Okay.
Yes. Hey. Yeah.
Sure. Yeah, I'll keep talking loudly and hope that everyone can understand me. I'm glad that everyone showed up this morning bright and early. Didn't have too late of a night last night.
Lab 1 is kind of low, too. That's what I'm on.
Or that.
It was both were. Hey. Test. That's fine. Okay. A little bit lower. Sweet. Thanks.
And let's see mine. Oh, mine I think is good.
It's good. Yeah.
All right. Thank you, everybody, for showing up. We have today, since we're late, I'm just going to run right into it. FireEye Labs Advanced Reverse Engineering Flare team here to talk to you, and I will let them go.
Thanks.
Sure. Well, thanks for having us, and I'm glad everyone showed up. Like I said, bright and early for us. We are really excited to actually get this conversation started, this presentation started. And I say started because the three of us have been working on this topic for the past few months, and I'll tell you, we have a lot to cover. So we'll do the best we can to cover in these slides here, and then we look forward to continuing the conversation with you afterwards, because we have so much more we're not even going to get to. So if you find yourself using any of the things that we talk about here in the presentation, or you used it before, or you're thinking about it in the future, definitely looking forward to continuing that conversation. So we're here today to talk about WMI, Windows Management Instrumentation, which is a really neat framework. Have people heard of WMI before? Is that why you're here in this talk? Awesome. I'm glad you're here then. So it's super powerful, great framework for configuring systems and inspecting them. And because it's so powerful for administrators and sysadmins, we found it's actually just as powerful for attackers. And this isn't strictly a theoretical thing. At FireEye, we have seen attackers using WMI more and more, and they're using it in very, very clever ways. And as defenders, people who come in and investigate these attacks, we realize that there's basically no way to investigate WMI persistence and payloads and lateral movement at this point in time. Sometimes you get lucky with network monitoring, and sometimes you can get hints here and there, but we realize there's no methodology in place. So our presentation here today is to talk about these attacks, talk about how you might investigate them, and also, for the first time in this kind of public release, talk about how you can actually perform forensics on the WMI repository database and really turn it into a good situation.
Cool.
So Matt here is going to bring us through an initial kind of case study that we'll work through.
All right, so consider the following attack. All right, this is just a proof of concept. I developed a really kind of primitive, crappy remote credit card or track data scraper, all right, where you install this payload remotely using WMI on the victim machine, given that you have credentials on the victim system, and we will see the following, okay? So I am about to provide credentials on my attacker machine, all right? I'm installing the persistent credit card scraper, all right? And what I'm doing is I'm storing the payload in the WMI repository in a persistent fashion. The payload that's going to execute is upon triggering our fictitious payment processor.exe, this payload is going to fire. So WMI is an inherently asynchronous technology that responds to events, and when those events trigger, there's a payload that's executed. So we'll see what that is, okay? We're storing it persistently, and the output of the scraped credit card track data is going to be stored persistently in the WMI repository. So here is our fictitious PowerShell payment processor.exe, where I'm putting in some fake track data. Okay. So payment processor.exe launched as soon as it was closed. The payload was scraping it while the executable was running, and now we can pull back the parsed credit card information remotely. okay? And in fact, I'm pulling it back as a serialized PowerShell object. So you probably just saw what was output was like the fully parsed track data that was collected remotely, pulled back using nothing but WMI as one, a persistence mechanism, and two, a pure WMI command and control channel.
Yeah. And this is not just a theoretical demo. We have seen attackers do this, and you go in and investigate it. There's no files to look at. There's no registry keys to look at. You're out of luck at this point, basically. So let's dig into what we can do about this.
And I'm sorry, I'm not going to be providing the code for that credit card scraper. There's no legitimate use for that. I'll be releasing a backdoor later at Black Hat, though. So keep an eye out for that. All right.
So real fast, I know let's do introductions. My name is Ballenthin. I work on the FireEye Labs Flare team. I'm a reverse engineer. And prior to that, I did a lot of incident response, doing forensic analysis and triage analysis.
I'm Matt. I'm a reverser on the FireEye Flare team. I'm a speaker, Black Hat trainer, along with Claudio, and I'm a huge PowerShell fanboy. Some of you may have heard of PowerSploits, one of the more like recent PowerShell projects that I've done. Considering like I do reversing full time, is called PowerShell Arsenal. So it's just like a little PowerShell module that helps you with some limited case studies in reverse engineering if you're a PowerShell fanboy like me.
My name is Claudio Teodorescu. I don't have a middle name. I didn't even review the slides, so I don't know what's that in the middle. But I think it's English pronunciation of my last name, I guess. But anyway, so I'm a reverse engineer at the Flare team. I did forensic for a long time, for almost 10 years, writing a lot of parsers for Encase. I'm a crypto analyst as well, and I wanted to play soccer, but my parents sent me to school, so, but I still had the passion for it. So, what we're going to talk today, we'll talk about the background, motivation, and some examples of attacks, the WMI architecture, the query languages by WMI, which is WQL. We'll look into eventing next. Also, we have a timeline of a breach history, a timeline of the WMI attacks. Dive a little bit into the providers. And then we talk a little bit about the format of the database, investigation, real-time defense and mitigations. We did a lot of forensic work on the WMI, so we'll present a brief introduction to it, and the white paper will have the details of the forensics of the WMI repository. Then we have a mock investigation of the credit card scraper that Matt presented, and then we'll present some attack detection that will help us mitigate the risks.
So who wants to try to see us do this in 40 minutes? We're going to try.
All right, so let's talk about the basics. I know most of you are already familiar with WMI. System administrators have been familiar with this like from day one, right? It's a really powerful system administration utility that allows you to pull back either locally or remotely all kinds of really valuable information, right? So you could enumerate running processes, enumerate services, pull back registry keys right to the registry. WMI also enables you to subscribe to events. So this is one of the most powerful features, in my opinion, of WMI that attackers have been using heavily, and as I'll show you later on, can be used just as effectively as a defender to detect attacker activity in real time. All right. So WMI has been around forever, like literally. The service has been running since Windows 98 and NT4. Okay, so all of the attacks and defenses that we're going to be talking about today, this applies going back to these systems. So I'm sure some of you have seen the occasional like NT4 system like just sitting in the corner somewhere that no one has any idea even exists. Well, it's listening on the WMI service. So if you were able to obtain credentials to it, then you can persist your payload on there, perform all kinds of recon. Really, like any stage of the attack, post-exploitation, you have WMI to carry out every phase. Okay, there's a bunch of different ways to interact with WMI. My favorite, and it's definitely the best by far, that's independent of me being a huge PowerShell fanboy, is PowerShell. All right, need I say more? But I wouldn't be doing it justice if I didn't explain a little bit more. So right out of the box in PowerShell, we're looking at, this is PowerShell 3. It comes with a bunch of built-in commandlets. So commandlet is just like a little function, basically. Think of it like a Python function, right? If you're not familiar with PowerShell. Going back all the way to V1 of PowerShell, you have all of these WMI commandlets. Okay, and starting with version 3, you have all these sim commandlets. Really, the only difference is the sim commandlets provide a little bit more flexibility over the WMI ones. Primarily, the fact that they can speak 2 different protocols. So the legacy protocol, which the WMI commandlets talk, DCOM, so port 135, and then an additional like randomly assigned port. They all talk those, but the sim commandlets also talk WinRM, which is like the Microsoft officially sanctioned like remote administration protocol that's listening on default now, like as of like Server 2012 R2 and above, I believe. Okay. Also worth noting, there's a bunch of additional utilities that you can use to interact with WMI. I'm sure many of you are already familiar with the command line interface, WMIC.exe. Yeah, so that's really powerful. It does have some limitations, but yeah, really like PowerShell extends all of that. And by nature of PowerShell being PowerShell, everything is an object versus like your traditional command line utility where all the output is text. Okay, I love objects, and the fact that you can pipe objects to other objects. PowerShell is amazing. Some other utilities, one of the lesser known ones is if like the PowerShell remoting or WinRM service, I kind of use those interchangeably, are listening, you can use winrm.exe to enumerate PowerShell objects, enumerate WMI objects, invoke WMI methods remotely. So many of the same features that like you may be accustomed to in wimic.exe, you can also do in WinRM if that service is up and running. So it's just an alternative. Also, another one you may not be familiar with is wbemtest.exe. So it's this like horribly shitty GUI client application for WMI. It's actually really powerful though. So if you run into a situation where like you're dealing with like app whitelisting and say like wimic.exe or PowerShell.exe are blocked, look for wbemtest.exe. Maybe you have permission to execute that and like enumerate WMI objects, execute methods, and whatnot. There's some additional utilities like Microsoft Sim Studio is useful for researchers that are interested in like viewing the WMI repository, inspecting all the classes, namespaces and stuff. So we've used that heavily in this research. All right. One of the primary means by which you interface with WMI is via the WMI query language. So this is a very simple SQL-like syntax that allows you to, 1, enumerate WMI objects, and 2, subscribe to events. So the syntax is only slightly different depending upon what you do. All right? There's 3 main classes of queries. Instance queries, where we're after the WMI class instances. Event queries, we want to subscribe to some event, either locally or in a permanent, like persistent fashion. And meta queries for those who are interested in discovering what WMI classes are available. All right, so here's a sample instance query. You see the syntax up above. So this is a really simple one. So select star, return all properties of all instances of the Win32 process object. All right, so this is the kind of syntax you would use to just enumerate running processes, where the name of the process is like Chrome. Okay, so just give me all Chrome processes. Okay. Instance queries are pretty simple. All right, event queries are a little more complex. There's a little bit more of a learning curve here. I'll touch on this briefly a little bit later, the difference between intrinsic and extrinsic events. But let me just go over these examples here. So the first one, select all instance creation events. So this is a very generic event that's going to fire all the time. So we have to constrain it a little bit. Instance creation event fires upon creation of literally any WMI class instance. All right, within 15 seconds, so we're going to like set a polling interval there, where the target instance happens to be a Win32 logon session class instance, right? Where target instance.logon type equals 2. If you were to just look this up in MSDN, you would see that this would trigger upon interactive logon. All right. Select star from Win32 volume change event. This is a type of extrinsic event that fires immediately, so you don't have to specify that polling interval, where event type equals 2. Okay. So this would refer to a user inserting removable media into the system. So from a defensive and offensive perspective, start thinking about some of the implications of this here. All right. Select star from registry key change event, where hive equals HKLM, current version run. Okay. I think that's kind of self-explanatory. All right. Eventing. This is, to me, the killer feature of WMI. All right. So there's 3 requirements in order to set up a either like local or, well, specifically here, a permanent WMI event. All right, this persists across reboots. There's nothing present on disk except in objects.data, which these guys will cover shortly. You need a filter, which is that event query that we just covered. Okay, a consumer. Upon triggering that event, what do you want to do? What payload would you like to execute? There's 5 different classes of these payloads or consumers that I'll show you in the next slide. And then the binding. This is the registration mechanism for binding the filter and consumer together. So the event and the payload that you want to execute, this binds them together. So this can be done both locally and remotely. All right? Oh, and permanent WMI events, yes, they all run in the system context. Pretty cool. All right, 2 types of events, intrinsic. In WMI, you have a bunch of namespaces, all right? And there are classes hierarchically organized within each one of those namespaces. Within each WMI namespace, you have a bunch of these types of events. So I showed you before, there's a like instance creation event. So any object that is instantiated within that namespace, that event's going to fire. Okay? If a namespace happens to be created, namespace creation event is going to fire. If a WMI class is created on the fly, as has been done by a particular threat group called APT29, you would see that a class creation event would have fired. All right? Extrinsic events. These are special types of events that I mentioned before. These fire immediately. All right? So they're kind of like specialized, very high performance classes. There aren't that many of them. So here's some example ones that you may find as an attacker or a defender to be of interest. All right, computer shutdown event, maybe do something upon someone shutting down the computer. Process start trace. All right, so maybe you could implement a kind of cool, like do some process like command line auditing using that type of event. Module load trace. Anytime any exe, DLL, system driver is ever loaded, this event will fire. Volume change event, insertion of removable media, kind of cool. Registry key change event, value change events. Just really start thinking about the implications of these and just how powerful these things are. All right, the consumers. You fired an event and you want to execute something, okay? There are 5 standard event consumers provided by Microsoft. Log file event consumer, okay? An event triggers. You want to capture that data and append it to a log file. Pretty straightforward. Active script event consumer. Attackers love this. This allows you to embed any Windows script host script, i.e. VBScript or JScript, into your permanent WMI event. Okay, so you're not dropping any script or binary to disk. This is all inline, stored in the SIM repository. So a single file which AV cannot touch. Okay? Anti-event log consumer, kind of like a log file event consumer, create an event log entry, and then as a defender, hopefully you're taking those event log entries and forwarding them to a centralized server. That's a smart thing to do. SMTP, send an email, okay? Command line event consumer, also obviously very popular amongst attackers. All right, execute any arbitrary command line executable upon an event triggering. PowerShell.exe, dash encoded command, create like a web client and then download some like PowerShell text and then call invoke expression on that, right? So you got like, you have like your little like one-liner PowerShell command stager execute upon firing one of these events. All right. So permanent WMI events, again, you need those 3 requirements. You have to create instances of each of these objects. The filter, i.e. your query, the consumer, what you want to execute, and then the binding together, filter to consumer binding. All right, let's look at some possible attacks here. Let's go back in history a little bit though. So as far as I know, WMI attacks publicly go back to 2010 with Stuxnet. So what Stuxnet did was one of the many exploits included in this package was it exploited the Windows print spooler vulnerability. I think this was like MS-10.051, where basically it enabled the attacker to, this was like an arbitrary file write vulnerability, right? So imagine on a Windows system, if you could drop any file anywhere on the file system, what would you do to gain code execution? So these attackers were pretty smart, and they thought to drop a moth file. So, and in this moth file, it consisted of instance creations of those event filters consumers and that filter to consumer binding. Okay, so you drop this file into a particular directory, and then mothcomp.exe would come around at a regular interval and consume any new moth files in this directory, and so it would eat that up, and then it would that text file would automatically be persisted in the database. So it, by nature of being a permanent WMI event consumer or subscription, would execute the malicious payload in the system context. So Stuxnet, they use this as a privilege escalation vulnerability. Microsoft patched that, so that like watchdog, like mothcomp.exe, can no longer just eat up random moth files that are dropped. You have to explicitly compile your moth files now at this point. There's a ghost payload. I believe this was some commodity malware that came out in 2010. It used permanent WMI events as a means to exfiltrate any newly created or modified documents within the user's like My Documents folder. All right. There's a really cool tool released recently by a French researcher. His name is escaping me. I'm sorry. Called WMI Shell. This was the first case that I saw where WMI was used as a pure C2 channel. So what he did was he created and modified WMI namespaces dynamically. And since you can do everything remotely in WMI, so like you can create WMI namespaces and then say like as the name of your namespace, it would be say like an encoded PowerShell command, right? And then you could use like the Win32 process create method to pull that down on the local system, decode it, and execute it. So this thing was pretty cool. And then there's APT29. FireEye just released a white paper about some of their TTPs. It doesn't actually cover any of the WMI stuff though. So they use some pretty cool like .NET stuff, and like they use like Twitter as a command and control server. But what they don't cover is all the WMI techniques. So they were using permanent WMI subscriptions in addition to, so kind of like WMI Shell, instead of using namespaces, they were creating WMI classes on the fly remotely. And so you can create a class and then create a class property, and then within that property, stuff your payload, all right? And then execute that payload remotely using the Win32 process class, store the result of that payload into another property class. So this is exactly what I was doing in that credit card scraper demo, the TTPs that APT29 were using. So very novel, unique techniques that they were using. Cool stuff. We know going back to 2010, we have an instance of these attacks. For all we know, some nation state could have been using this, since the advent of Windows 98 or NT4. I have no idea. Okay. So WMI can be used to, like in any portion of the attack lifecycle. So remember, you can do everything remotely with WMI with proper credentials. So reconnaissance, you can do VM, sandbox detection, code execution, lateral movement, persistence, data storage, like what APT29 was doing, or C2 communication, like what APT29 or like WMI shell was doing, like using WMI as a pure C2 channel. All right. So if you were to go about doing some recon activities with just WMI, here are some of the classes that you should maybe be interested in. All right. We can do file directory listings by enumerating SIM data file instances, Win32 volume. All right. STD reg prob. This is what allows us to perform registry operations, read from any registry key or value, write to them. Okay. So you could use that as a persistence mechanism too, like write PowerShell.exe -encoded command to the run key, yeah? Okay, service listing, event logs, logged on accounts, installed patches, AV. This is just a very small sampling of what might be valuable to an attacker when performing recon. All right, code execution and lateral movement. I love this stuff. Attackers have been doing this for a while. You have probably done this like using like WMI.exe, by calling the static create method in the Win32 process class. Yeah, so here I'm just doing it in PowerShell instead using invoke WMI method. All right, so I provide the computer name or host name, and then the credentials. It'll pop up and let me type in the password. And then in the argument list is what I want to actually execute. So just imagine replacing notepad.exe with like PowerShell.exe-encoded command. Okay. So, remote code execution. It's awesome. Okay, again, just a refresher. This is what we need for permanent WMI subscriptions, i.e. persistence, using WMI. So, here's a practical example of where this was used in CDaddy. I think like that's the Mandiant family name. I think this was like referred to as like CDuke. CDuke. Yep. Yeah, CDuke. So CDuke was, well, one component was like pure Python backdoor, and then within that Python backdoor, the means by which they persisted was they ran basically the following PowerShell code by calling PowerShell.exe with following payload. So the query here is, which the attacker basically ripped right out of my PowerSploit persistence module. This like super shitty query where it's just going to trigger like shortly after system startup. All right. So what's it going to execute upon triggering that after startup? Just here down towards the bottom, the WMI event consumer. It's command line event consumer. What are we going to execute? An executable that was previously dropped by the Python backdoor. Or I think this was the actual Python backdoor itself that was executed after system startup. All right. So kind of a crude like persistence mechanism. I don't really think this is that stealthy. I mean, it relies upon a binary to be dropped. Like if it was me, I would remain like super stealthy and not drop a single binary or script to disk because WMI enables you to do just that. All right, so data storage. I already talked about this. This is what APT29 was doing. Here's a very simple example of how you would go about doing that in PowerShell just remotely. Okay, there's just a few additional .NET classes that you would have to use in order to take this code and be able to store arbitrary data remotely on a system by creating these WMI classes. All right, providers, Willie.
Yeah. So I got to admit, when I started looking into WMI, I was pretty impressed with its architecture. I came in expecting from a Linux background that's going to be this huge monolithic like service with a bunch of components, and I wasn't going to be able to play with it. Well, that's not actually the case. WMI is kind of architected in a very nice way. It's really just a framework. And the core part of WMI is very small, and it delegates a lot of the responsibility for creating these instances of classes and the types of things you can query to providers. Okay? And a provider is a thing that defines what you can query for. And when you ask for a query, what data you get back. Okay? And Microsoft ships with a default set of providers, and those are the things that Matt's been describing the past couple minutes. But of course, we can continue to extend and provide our own providers. So when you get a new Lenovo laptop, for instance, if you go in and enumerate all your providers and the things that are exposed via WMI, you see Lenovo's actually developed additional code that allows them to kind of remotely inspect your system. I'm not saying they do, but an administrator could go in and say, how's the system looking? How does the BIOS, how's that set up? All right, so this is a very extensible format.
Let's modify the BIOS too, remotely. Yeah.
Don't want to get into that here. But, putting my attacker hat on or my defender hat, I'm starting to think, like, what else could I maybe expose through WMI? These are, again, WMI you can control remotely. What could we do by adding additional providers, additional data that we could collect from the system? I think, Matt, you found some of those things.
Yeah, so like we had like a Skype chat where we would coordinate our research, and Willie brought up a long time ago, like, hey, wouldn't it be cool if maybe an attacker decided to extend WMI by creating their own malicious provider, right? So like an example of a legitimate one, like take Win32 process, right? So there's a DLL that actually populates instances of running processes via this Win32 process object, right? Well, as an attacker, right, you can, well, in WMI you can create class instances. You can also execute methods, right? So this recently went from theory to reality when I reached out to some buddies. Casey Smith sitting here. Is Jared here? No, lame. All right. So I basically provided them what my requirements would be as an attacker. Like, hey, I would love to see a malicious WMI provider. Well, Casey banged it out in one night, and I was just blown away. So what he did was he created a malicious WMI provider in the form of a .NET DLL, and the way you would go about installing that is you just call install util.exe, provide the path to that malicious provider, and now you have these magic malicious WMI classes that didn't exist before. So what he implemented was a shellcode runner, right? So a shellcode runner that happens to run in the system context. That's pretty awesome. So with this installed locally, you could execute your shellcode payload locally, but you could also do so remotely, all right? So here's how you might go about doing it. Call invoke WMI method. The class name, he called it Win32 evil. Exec shellcode is the name of the method, and then you just provide your shellcode byte array. And then you could append the dash computer name and dash credential and do all of this remotely. Okay, Jared did something very similar. He's more defensively minded in general. So when he set out to do this, he wanted to be able to enumerate all active network connections, because you can't do that in Windows 7 and below. In Windows 8 and above, you do have classes that enable you to do that. But he wanted to be able to do this for any arbitrary operating system, right? So he created that class, so that's pretty cool. But he also kind of slipped in there the run PS method, which allows you to execute just an arbitrary PowerShell script in the system context. And so I believe the way he implemented it, it wouldn't even call PowerShell.exe. All right.
That's cool.
Yeah.
So I hope we've motivated you at this point of thinking hey, this WMI thing's pretty cool. We have a lot of capabilities. We have a lot of ways to stay under the radar. And as a defender, and I'm thinking, I'm man, this kind of sucks. I have nothing that I can do to detect this and find it and do forensics. So let me talk about precisely how we came about this. In the past 6 months or a year, I've worked a couple larger engagements. We're talking 10,000 hosts, 100,000 hosts. And we're seeing this group we kind of call APT29. And they come in, and it's been really exciting. Because this is probably my favorite threat group that I've worked with recently, because they're really good at what they do, and they develop new techniques rapidly, and they deploy them, and they almost test in production. They just throw things out there, and they're like, hey, maybe it's going to work. And so one of their kind of interesting attributes is that they seem to know a lot about forensics. They know what the defenders do, and they actually do a little bit of targeting of defenders to kind of figure out how they're being detected on a network. And so when we go in and actually work with clients that are targeted by this threat group, we're kind of in an arms race with them. Sometimes we can get them out right away and they come back in, or sometimes we chase them around. And as we do that, and they realize that they're getting kicked out, they deploy newer and newer techniques. And so very quickly, within the first couple of weeks of us doing some of our investigations, they started deploying things that we had never seen before. And one of those things was a lot of these kind of WMI ninja tactics, all right? And we realized as we're doing this, there is not much out there. It's very difficult to do forensic on these boxes. Now, we got really lucky because we had really good network visibility and host-based visibility, and we can basically watch all the commands they were running and figure out all this stuff. But what worries me is, what about those clients that we're working for where we don't have that visibility? You know, there's really no chance that we had to actually identify this. And so that got us really worried. So in these clients, you know, we're kind of thinking about, well, what can we do right now to actually investigate a system, to do forensics on it? Well, naturally, we can use WMI to inspect itself. And I think at this point, you can kind of see how that would be done. We could write some WQL queries that inspects itself and like gives you all those persistence items, for instance. But that makes me kind of worried as the defender there. We already know these threat groups that we're going up to are fairly advanced. They're using new techniques, and they have rootkits. They have other really advanced pieces of malware. I'm thinking if I'm using the running system to inspect itself, there's no way I can really trust those results. I might get lucky. Maybe it's truth. Maybe it's not truth, and I would never know. All right? Another issue with that is I have to have the system live and running on the network and me have credentials on it. Sometimes all I get is a forensic image, and then I don't have a running system, and I can't use WMI to query a dead box. So for a long time, more than a year actually, our best recommendation to our forensic investigators was to run strings on this one file and guess at what that meant. And it was like, that is not forensics. That's not going to hold up in court. And sometimes we get lucky and we can guess at what it means, but it's not forensics. And the final technique that we found kind of worked was to basically build this Frankenstein system where we could copy over the SIM repository from a dead box to a live box and then cause the system to re-ingest the file, and like, it sort of worked, but I had no idea what the system was doing. Was it performing auto recovery? Was it cleaning up things that weren't supposed to be there? I couldn't tell you. So even though I could get some data out of it, I didn't know why I was seeing that data. And so as a reverse engineer, as a forensic analyst, I was not happy with that technique. So naturally, we went ahead and we said, well, what can we do to reverse engineer this? Is there a way that we can do real forensics on the artifacts? So we took a look at the files in the file system that are related to WMI, and specifically the SIM repository. All right. Recall our WMI providers define what data can be exposed and queried through WMI. All right. And this is all organized within this SIM repository. This is the common information model, which again just defines basically the scheme of what's going on and anything that's been persisted on the system. So like those persistent techniques and the filter to consumer bindings that we talked about a minute ago, those are stored in this SIM repository. Has anyone doing forensics before seen this objects.data file? Maybe I had definitely seen it while doing forensics. If you do a string search for your malware binaries, sometimes you find entries in this file. And then you go to look at it, and it's this weird structure. It's not a known database format. And so you know that there's something good in there, but you don't know what to do with it. In the same directory, there's this index.btr file, which has a bunch of crazy hash-looking like strings that look kind of like hashes, but no kind of useful data to the human eye. And then there's a couple other files there, and they're all kind of related, but we really didn't know what was going on. So we spent some time reverse engineering this. We're a team of reverse engineers. So we basically pulled out our hex editors. We looked at dumps of the database. We actually did not do any static analysis of the services. We did not debug the system. We just looked at these hex dumps of the file formats. We said, hey, that looks kind of like a string. And this field over here, that kind of looks like a pointer to this string from the start of the record. And then within that, hey, that kind of looks like a set of flags. And so by doing a little bit of differential analysis and a lot of late nights in front of the hex editors, we were able to basically completely reverse engineer the database format. There's, I think, a total of like 4 bytes in the entire database that we don't know what it means. This is really good. What this means is that we can do forensics on these WMI databases offline on any operating system. We can do it on Windows, Linux, Mac OS X. We have that ability now. So this is really good news. So let's talk a little bit about that. Claudia?
So yeah, I'll be brief on this. All the details are in the WMI white paper. Is an easy read, close to 100 pages.
It's coming out later today on the Flare website. Yeah. The FireEye blog.
So the diagram shows the files the repo consists of and their collaboration and relationship. So we have the index BTR, which is a B3 on disk. It's paged. The page size is 200 hexabytes, and everything in the index BTR is any page in the index BTR is represented by a logical page number. A logical page number is translated into a physical page number using the corresponding mapping in the mapping.map file. Here is the actual information about the object. It's found in the objects.data. Here is an example of an evil consumer. The NS underscore and then the ID, that's the ID of the namespace. The next ID prefixed by CI underscore is the representation of the class of the instance, and then the IL underscore, and then the identifier follows is the identifier for the consumer. There are three integers following. First integer is it's the logical page number for the record containing the data for the instance. That's logical, and you have to go to the mapping, to the corresponding mapping data for the objects.data to get the physical offset. Use the second integer to identify the metadata for that record. In that metadata, you have the index inside the page of the record and the size. You use the physical page multiplied by the page size, which is again 2000 hexa, and add the index in page, and you get to the offset of the record containing the instance data. Here is a representation of a page in the B3. It's very powerful, and details are in the white paper. That's kind of what we cover in the forensic.
Yeah, the takeaway there, I mean, that was a crazy diagram. It's like a rainbow, wasn't it? Did anyone understand it at that point? I mean, there's some good hackers in here, right? If you didn't understand it, not a big deal. Like we said, we're releasing a white paper this afternoon. It's nearly 100 pages long at this point, where we're diving into deep detail about how to do this parsing, what it means from a defensive and offensive perspective, and all those details that you need. So if you feel like we were a little short on this stuff, take a look at that paper and then come back to us and let us know what you think about it. So naturally, we figured out what the database structure was. We want to share that knowledge and actually build tools that allow us to work with these files. And so that's what I want to talk about here. We're also releasing those today. I pushed on my code this morning. Claudio also pushed his code this morning. We now have forensic parsers for these SIM repositories. Okay? They're on GitHub. I personally wrote this Python SIM module. It's a pure Python script, a few thousand lines long, that implements the database driver that allows you to query the system. Okay? Anything that's in that database you can now work with. It's very easy to use. I don't know, I think it's very easy. How do I do the demo? Next slide?
Yeah, I'll start it for you.
All right. So let's see. Oh. How can I pause it? All right. Right. It is a library. The library is quick to use, simple to use, but naturally that's not great for demos, so I built a nice little GUI for it. Let me walk you through it real quick.
It's going.
It's going, all right. A couple different tabs there. We can explore the physical structures of the database, but if you don't know what that means, don't worry about it, because we can also explore the logical pieces of data in the SIM repository. Here we're exploring some of those namespaces. Root SIMv2, default namespace used by WMI. Additional namespaces, like down here, root subscription, is where you would find those filter to consumer bindings. Okay? So we can explore them, see the data that's there. These are all those things that you could use WMI to inspect itself, but we're doing this offline. We're looking at the SIM repository pulled from the system that Matt showed at the very beginning. Here's a class definition of the filter to consumer binding. All right, this allows us to understand what kind of data is in that class, what kind of data is stored, and what we find is some additional timestamps that are not exposed by WMI that you can use as a defender to understand what was going on in a box. You can timeline this stuff. Down at the bottom here, we're seeing all the different properties and fields within this specific class, and as expected, there's a filter, there's a consumer, and this is the binding between the two. There's additional kind of deep detail here, if you're interested in it, that allows us, that we're able to parse out. but all the basic features are there. One of the cool things about this tool here is that it also shows you how it's parsing out all these forensic details. So here we have a pretty standard hex view there. We can scroll up and down, select data. But additionally, we're able to explore how this data is being parsed. So for instance, there's the header at the top there. We can dig into the header. We can look at where is the name of my class? Where are these timestamps? How is the tool actually getting to this data? And so we're able to basically confirm what the tool is telling us manually. So if there's ever anything that doesn't make sense to you, you can always double check it right in line on the tool there. That's pretty powerful. All right, so we took a look at this is the class definition. This is the type of data that you can query or might be on the system. The next thing we should probably do is take a look at the specific instances of this filter to consumer binding, the things that are installed for persistence on this specific system. So that's installed. These visible inline here in this tree view. We see that there's 3 of them installed. All right, and we can look at the concrete values that are stored in each one of those instances. So this is another filter to consumer binding. 2 timestamps here. We conjecture this is creation and modification date for this specific instance. We see what the 2 things, 1, what the trigger is, and 2, what the payload is that's going to execute. These are references to additional data that we'd want to take a look at. Similarly, we can explore how the tool is extracting this data. All right. So that tool is really neat. It allows you to kind of intuitively explore the data, and it's very easy to use. It works cross-platform. You see I'm using it on Windows there. Claudio's going to take a minute or 2 to talk about his tool, which is written in C. It's very fast. And if you don't know too much about WMI, if we didn't do a quite good enough job in our presentation here, Claudio was able to encode a lot of the knowledge and a lot of the methodology that we've developed over time into his tool. And so it's kind of a one-stop shop for getting a lot of the things that we know about. And if you want to kind of explore it on your own, that's when I recommend you use this kind of Python tool to explore and see what's there. So Claudio, can you walk us through this?
Yep.
And we're going to keep presenting until they kick us out. So bear with us here.
So this is a tool done from the IR perspective, more to find out what's happening in your system quick and dirty. First, we are looking for all the consumers available on the system. You specify the default namespace, which is a root subscription. And then you get all the consumers available. We have first the command line consumer that is named test consumer, which it does executes a PowerShell payload, which is located in the Win32 underscore payload class. Next is an anti-consumer log event, and then another command line event consumer, which is BVT consumer. These 2 consumers are present in most of the computers, so nothing wrong there. The first one looks suspicious, though. Now we are taking a closer look to that consumer by name, and then we found out that he's executing a PowerShell, is taking the information from the Win32 payload class and from the property called payload. And the default value is actually the encoded payload. And then we found out the filter to consumer binding that matches the event that triggered the test consumer. So it's named payment card processor launched. Now let's take a look at the event filter named payment card processor launched.
Did I cut you short?
And we see what's the trigger event, which is the start of the process payment processor.exe. Once we have that,
We move on.
We have all the information we need, and then we go analyze the payload, decode it, and see what it's doing, and see where the track data is stored.
Yep. Yeah, so using Claudio's tool, you would be able to dump the actual payload, that credit card scraping payload, dump it to disk, and perform further analysis. So these are pretty amazing tools here for performing forensics. Now, real quick, so we have offline forensic parsing capabilities, which never existed until today, okay? Now, you can also use WMI to detect this stuff in real time, all right? So as a defender, start thinking, okay, when an attacker performs WMI persistence, it creates WMI objects, okay? we can tap into events that detect creation of those events, and we can respond accordingly, create an event log, log to a file, right? So, so basically you can use WMI as a defender against attackers itself. So it's WMI on WMI action here, all right? So start thinking about the implications here, okay? WMI is basically the agentless WMI, or the agentless host-based IDS that you never knew existed, okay? And it's built into Windows. So I released a proof of concept tool, WMI IDS, that will detect certain components of attacker activity. I plan on extending its functionality. It is very beta at this point, so I'd like to gauge interest and continue to add to it. I have a brief video that shows how I was able to detect the credit card scraper in real time as it was installed, and all it did was create an event log entry. Okay? So the takeaway here is that you can use WMI against attackers using WMI, and there's some other detection utilities out there. Lastly, I'd like to thank Will Schroeder and Justin Warner for helping me out with like really interesting like use cases for event filters. Our Manient IR guys, the ones who are performing the actual APT29 investigation, those guys are awesome. And of course, APT29, thank you very much for allowing us to create these tools and just step up our, create new tools and be able to investigate things even further. All right, we have a reversing challenge, flareon.com. Check it out. Thank you very much.
Thank you.
Awesome. We have just a couple of minutes for questions. If anybody does want to have a question, there is be a microphone right here.
We'll also take questions outside. We'll be hanging out for a little bit.
All right, nobody? Okay, then two things. Announcement. There was a cell phone in a blue case left in a taxi this morning. It has been turned into hotel, so go talk to the hotel if you lost a blue cell phone. Also, please pack it in.